Welcome back to The Explainer. Today, we are unpacking a truly fascinating irony sitting right at the very heart of the clean tech revolution. We're drawing our insights directly from the SASB Sustainability Accounting Standards, specifically looking at the fuel cells and industrial battery sector. And, when we think of industrial batteries or fuel cells, we naturally think of green energy, right? Sustainability, saving the planet. But there is a massive paradox hiding in plain sight on the factory floor, and it is completely reshaping how investors and companies look at this industry.
It's the million-dollar question, isn't it? Why is the very industry building our clean energy future suddenly struggling with its own massive power demands? Just to be clear, we aren't talking about the small batteries in your TV remote or even the ones in an electric car. According to the SASB standard, this industry focuses on heavy-duty energy production and storage equipment. We're talking commercial business applications and massive utility-scale energy projects. And building these monumental clean tech solutions is, ironically, hitting an incredible energy wall. And this brings us right to our central paradox. On one side, you have the product itself. Innovative, clean energy storage and highly efficient fuel cells designed to shrink our carbon footprint. But on the other side, the process. The reality is that building the tools to save energy actually requires an astonishing amount of electricity. It is a highly energy-intensive manufacturing process. You literally cannot build the green technology of tomorrow without consuming a vast amount of power today.
Section 1. Massive manufacturing power drains.
Let's actually step onto the manufacturing floor for a second to see exactly where all this energy goes. The SASB standard lays this out super clearly. Manufacturing in this sector requires continuous, heavy energy consumption across 3 specific stages. First, you have to power the heavy assembly machinery. Second, climate control. These aren't your standard warehouses. Building industrial batteries requires pristine, clean room facilities with massive, power-hungry cooling and ventilation systems running constantly. And third, rigorous product testing. You have to thoroughly charge, discharge, and stress test these industrial-scale units before they ever leave the facility. It brilliantly illustrates just how demanding the process is before the product even reaches a customer. The standards highlight something huge here. They state that purchased electricity is a major share of the energy sources used in the industry, and it accounts for a notable proportion of the total cost of materials and value added. I want you to really absorb that. This massive energy drain isn't just some abstract environmental concern. It's a colossal line item on the balance sheet. Every single time they power up those testing systems or run that clean room ventilation, the meter is spinning and it is eating directly into the cost of creating the product.
Section 2. Squeezing tight profit margins. So let's shift from the factory floor to the boardroom, where we find a really precarious financial vulnerability. Here's a stark reality highlighted in the SASB framework. Many entities in this sector are operating on relatively low or even negative margins. Let that sink in for a second. The companies building the very infrastructure for our renewable future are often barely scraping by financially. When your margins are that razor thin, a high overhead cost isn't just an annoyance, it's a potential existential threat to the whole business. So map that out in your head. We see a really dangerous relationship taking shape. Various sustainability factors are actively increasing the cost of conventional grid electricity. And as the cost of conventional power goes up, it acts like a vice grip, directly crushing those already shrinking operating margins. When electricity accounts for such a big chunk of your total material costs and that electricity keeps getting more expensive, well, those low to negative margins are pushed to the absolute brink. Section 3. The renewable financial necessity. How does the industry actually survive this margin squeeze? Through a strategic, financially driven pivot to alternative energy. As the SASB document points out, there's a crucial dynamic shifting in the market right now. Conventional grid power is getting pricier, but simultaneously, alternative energy sources are becoming highly cost competitive. This changes the entire conversation. For a fuel cell or industrial battery manufacturer, adopting alternative energy is no longer just some nice PR move or a greenwashing tactic. Because of the intense pressure on their margins, transitioning to renewable energy is now a strict financial necessity for survival. The crucial takeaway is this amazing twofold benefit. By improving manufacturing process efficiency and tapping into those cost-competitive alternative energy sources, these companies hit 2 vital goals at the exact same time. First, they reduce their operating expenses, which drastically improves operational efficiency and profitability. And second, they reduce their indirect environmental impacts. It's this perfect alignment where saving the balance sheet literally means saving the environment. Section 4. Tracking the energy shift.
Knowing how critical this transition is, you might be wondering, how do investors actually track it? Well, it comes down to rigorous sustainability metrics. Under the energy management topic, the SASB framework uses metric RRFC 13A.1. This is how the industry is held accountable. Investors demand transparent, standardized reporting on exact energy usage and sources. It's just not enough for a company to simply say they are going green. They have to prove it mathematically using very specific parameters. It all starts with the baseline metric, total energy consumed. This has to be measured and disclosed as a massive aggregate figure in gigajoules. And the standard is incredibly thorough here, guys. The scope includes energy from all sources. That means purchased electricity from the grid, direct fuel usage, heating, cooling, steam energy, and even energy the entity produces itself. Every single gigajoule directly consumed during the reporting period must be accounted for, no exceptions.
Now, what's really interesting is how that total energy pie gets sliced up. Once a company calculates its total energy consumed, it has to disclose two critical percentages: the percentage of energy supplied from grid electricity and the percentage that was renewable energy. This is how stakeholders can immediately see a manufacturer's true energy mix. If a company claims they're mitigating the financial risks of rising grid costs, this breakdown is exactly where they have to prove it, by showing a shrinking grid slice and a rapidly growing renewable slice. But hold on, they can't just call anything renewable. The SASB framework has very strict definitions. Renewable energy is defined as energy from sources that are replenished at a rate greater than or equal to their rate of depletion. The qualifying sources explicitly include geothermal, wind, solar, hydro, and biomass. And actually, it's worth noting that for biomass, the scope is strictly limited to materials certified to a third-party standard to ensure it's truly sustainable. There is one more fascinating layer to the accounting rules here. What if a company generates renewable electricity on site or buys a green power product? Can they sell the green credits to someone else and still claim they use renewable energy? The answer is a hard no. The standard mandates that renewable energy certificates, or RECs, and guarantees of origin must be retained, not sold. And they must be retired or canceled on behalf of the entity for them to claim it as renewable energy in their metrics. Basically, you absolutely cannot double count your green impact. Which brings us to a final thought for you to ponder today. We've seen that building the infrastructure for our renewable future requires a tremendous amount of energy up front, creating a severe financial tightrope for the manufacturers. And as they pivot to renewables to save their own margins, it fundamentally changes how we view the entire industry. So the next time you see a massive industrial battery installation or a commercial fuel cell, ask yourself, what is the true life cycle cost, both in raw energy and thin financial margins, of the clean tech you rely on every single day? Thanks so much for joining me for this explainer, and keep asking the big questions.